All right, good day, everybody. This is Matt Webb with UT Extension in Marshall County. Welcome to the lunch series today. We have our distinguished speaker today is Justin Hargrove, who is the extension agent in Benton County, but also serves as the Western Region Fisheries Responder. And I asked him a few months back if he'd be willing to come back and talk about ponds. He did so earlier in the year and did a good job, and we wanted to go back and look at pond repairs and construction. And so I'm very grateful that Justin has decided to do that for us today. So without further ado, we'll hand it over to Justin. Thank you so much, Justin.
All right, thank you very much, Matt, and thank y'all for joining us today. This is something that I get quite a few questions about, and as we'll see today, sometimes it's little tricky answering those questions and getting good coverage on that. We'll start out with a disclaimer. Disclaimer is I'm not a soil science engineer, also not a lawyer. My background is primarily ag business, natural resources from a biological standpoint. Deal quite a bit with managing fish populations and controlling aquatic vegetation, looking at that relationship between aquatic vegetation and fishery species. But with this job, we do also look quite a bit at pond construction, pond repairs, and overall structure. Whenever possible, if you're looking at building a pond, if you have got repairs that need to be done, try to work with your area NRCS or Tennessee Department of Environment and Conservation, as well as your pond contractor, to make sure that you follow proper construction protocol. There is a lot of science and a lot of engineering math that goes into this in order to do it properly. And most all of this presentation, or at least a good chunk of it, came from this Agricultural Handbook 590. That is a Natural Resources and Conservation Service publication. It's available to the public. The public paid for it. It was paid for with y'all's tax dollars. So this is something that is available to you, and it is an excellent guide for constructing ponds, and it's also got a good bit of information about repairing ponds in it. Today, we're just going to be scratching the surface. There's about 98 pages in this thing of engineering math, and we're just going to be scratching the surface of it, but hopefully it'll give you kind of a roadmap and some direction to take whenever you're considering building these ponds or repairing them. Another really good resource to consider is the Texas A&M Aquaculture Fisheries and Pond Management website. This is a very, very handy tool. I use it on a daily basis. It's usually the first thing I pull up on my tabs every morning, and I just leave it up all day long because I know I'm going to be visiting it 3 or 4 times. But it's got resources not just for building and repairing ponds, but also all of your other fisheries and aquatic vegetation needs and questions. So let's jump into it. When it comes to repairing leaky ponds, there is kind of a step-by-step process that we need to go by. First thing we need to do is try to identify the problem. And this may be easier said than done. Oftentimes I'll get calls from people and they just say, well, my pond is got a leak in it. I can tell because it's getting lower. I'm starting to see mud around the banks, and we usually don't see that. So get out there, examine the levee, look behind that levee, see if you can identify any easily noticeable wet spots, wetland vegetation such as bulrushes popping up. These could be indicators where you have got a seep, where that water is seeping through your levee or dam onto the backside and causing these issues. These can be caused by muskrats, crayfish, decaying tree roots, and what those will do, it'll cause kind of a channel through that levee that will allow water to flow through, and you get these seeps on the backside of your levee that can eventually actually cause your levee or dam to break and result in a catastrophic dam failure. Some of your older ponds, if they have got overflow pipes, they can actually develop leaks around those drains and pipes as that water flows parallel with the pipe. We've seen that quite a bit. In a lot of our new ponds, they're recommending to put a collar around that pipe in the midst of the dam to try and prevent these kinds of issues occurring around our overflow pipes. And then once you've checked on the back side, just go back over to the water side, check around that perimeter at the water line, see if you can find any obvious holes, any noticeable spots where you're losing water. And whenever possible, I know a lot of folks, they'll buy a piece of property that's got an existing pond on it and don't know a whole lot about that pond. Try to get as much history about that pond as you can so that we know what might be causing some of these issues. Was the site properly prepared? Whenever we get into talking about building these ponds in a little bit, we're going to be talking about removing topsoil, making sure that we clear out that vegetation. Because if we wind up with topsoil and vegetation compacted into our dam, that stuff's going to rot down, it's going to erode, and that's going to allow those water leak issues that we so often see. Was the levee constructed properly? Oftentimes, and as Matt mentioned, I'm located in Benton County over here in West Tennessee. A lot of the people that I deal with as an extension agent are beef cattle producers, my family included. Most of those ponds were built with just simply a bulldozer that's pushed up an embankment. They try to compact it with a bulldozer, just kind of thrown together. Proper construction, we want that levee to be constructed and compacted in 6-inch soil layers that have been compacted with a roller. I was speaking with a friend of mine that's a dozer operator last week, and we were talking about compaction. He said, bulldozers really weren't designed to compact soil. They're actually designed for the opposite, to spread that weight, to keep from compacting soil and to keep from sinking them if you're in wet ground. So bulldozers, while great for pushing that levee up, they're not good at all for compacting that soil. Was the pond bottom properly compacted? And is the area known for gravel, sand, or sinkholes? So that's something else that we need to consider is there the possibility that this water is seeping straight out the bottom of our pond due to poor soil structure and potential gravel beds there? Or for some of y'all,
there's an issue with it.
Is there fractured or jointed bedrock in the pond basin? So those are things to keep in mind when repairing those. So whenever we have got a leak, oftentimes it's going to be occurring at the dam, and we can see here ways that those leaks can occur. Oftentimes these leaks that are occurring up towards the top of the dam are going to be the results of things such as tree roots, muskrats, or poor soil compaction whenever the pond was built, as well as seeping all the way through the bottom there. So typically we'll find that wet area on the backside of the dam, and that's just a real good indication of what's going on with it. And so the next question that we get is, once we have got this, we figured out where the leak is at, what can we do to repair it? Some of our options include bringing in equipment and properly compacting that dam to try and stop those. We can also go in and drain that pond down. We don't want to bust the levee if possible, because once you've busted a levee, it's very difficult to get one to hold water effectively again afterwards. But if we can drain that pond down and come in and run a sheep's foot roller over and add some compaction, or if we can come in with bentonite clay or a clay blanket or a clay liner to help stop that, then that's also going to be able to hopefully provide us some relief from those leaks. Got pulled up here a breakdown of what some of the approximate cost per acre or approximate cost per square foot is for those kinds of repairs. Whenever I first looked at this, I thought, well, that's really not too bad. But then I got to looking at when these costs were put together. These cost estimates are based on prices from 1999. As I mentioned, my background is also in ag business, so I got down and I figured, calculated this for annual inflation. So based on annual inflation over a 20-year period, most of these prices have doubled. So you can take what you see here and effectively double it, and that is what it's going to cost you to repair your pond leaks on a square foot or square acre basis. So if y'all want to take a picture of that, that'll give you some idea what it's typically going to cost. There's not a cheap way to do it. And unfortunately, there's no guarantees once you have spent that money. With pond leaks, if you've got somebody with an unlimited budget that does everything right, there's still at best a 50-50 chance that this thing is not going to seal properly and that you will, within a few months or years, have this pond leak to occur again. That's why I like to tell folks that it's very, very important to try and take a proactive and preventative standpoint on ponds from the get-go. Once you neglect a pond and let it go and it gets holes and leaks, it's very difficult to resolve that. So the way that we can prevent that is try to control weeds and vegetation along levees. Some of the issues that I've been dealing with this year are coming from a lot of landowners and pond owners that have got trees growing along their levees. As we mentioned earlier, those roots will push those soil particles aside, and then as those roots die or as they move that soil, they're creating little channels and holes through the levee for that water to run through. And once you have got a hole that's running all the way through your levee, there's no really good way to plug that. So by practicing proper maintenance, mowing along those levees with a bush hog or mower, or just spraying to keep those trees and bushes from popping up, we can prevent those large roots from causing those channels from occurring through those levees. Also keeping an eye out for nuisance animals, muskrats, beavers, things of that nature. Both muskrats and beavers will dig into a levee and then up into it to create a den. And once you've got them, they are quite troublesome to get rid of. Typically, the only way that you're going to get rid of those is to call in a professional trapper to remove them. And then we can also reduce erosion by maintaining a proper spillway and then riprap along that levee as well. Oftentimes you've got the waves of the pond beating against the levee, and they can and will cause erosion over time. And then in these high rain events, a lot of times you'll see spillways getting blown out and washed away, and that in turn will really compromise the structural integrity of that levee. Okay, so from that, we're going to move on into considerations for construction. And while we speak of considerations for pond construction, we're also going to be touching on a few things that can also go back to pond repair as well. But the number one thing, the first thing that we need to look at is our site selection. Whenever we're looking at putting in a pond, we've got to consider the lay of the land of where we're looking at putting it in. So slope and drainage. Let's say you've got an area where you're looking at putting a pond. What all is going to drain into that pond is a real good rule of thumb for figuring out how much drainage area that you need per square foot or per square acre of water. You're going to need 2 to 3 acres of drainage runoff per acre foot of water storage capacity. So if we're looking at a 3-acre pond, ideally it's going to be needing to be fed by about 9 acres of runoff. We also need to strongly consider soil type. As we mentioned earlier, sandy soils are not at all going to be favorable for these ponds. We're also going to need to keep a close eye on rock outcrops, bedrock, fractured bedrock in particular. If you're in an area that's got a lot of limestone and things of that nature, there could be caverns that you can get into that whenever you're digging that pond, and at that point you've just got a hole in the ground that's never going to hold water. So I would really recommend you working with NRCS to try to get a handle on the type of soil that you're going to be dealing with. All of these soils are going to be different in their capabilities of holding water or their water holding capacity. So it's going to be important that you understand that before you hire a contractor to come in there and dig a hole in the ground. Ease of access. If you're building a pond for livestock watering, it's not going to be quite as much. You're not going to be trying to access that typically quite so much as what you would as if you're building a large pond for fishing and recreation. So ease of access needs to be taken into consideration as well. And are we going to be digging in an area where there are buried pipelines, cables, power lines, things of that nature? The last thing we want is to wind up getting in there with a dozer and fracturing a pipeline that's going to cause massive loss of life or loss of funds. So that's another thing to consider. And how is it going to impact any streams or creeks? This one is a much, much bigger topic than what I originally thought. I've spent quite a bit of time on the phone with Mr. Robert Baker with the TDEC. And the way that he was explaining to me is that if you are building your pond and it's going to impact a stream or a creek, you are going to have a permit from the state of Tennessee to build that pond, which is going to require someone to come out, survey the area, look at the overall flow through of this area, and how it's going to affect things downstream in order for this pond to be legal. If you build the pond and it's impacting things negatively downstream, or if, Lord forbid, you build it and the dam fails and causes massive loss of life and property downstream, then you will be liable and held accountable for these impoundments. So there is some liability that goes along with this that needs to be considered whenever we build these impoundments. So as we mentioned, dam failure, we want to consider the what ifs. Whenever we build these, what all is going to be downstream of your spillway overflow in the event that this thing fails. I've got some folks that I work with that are operating ponds that are 20 acres or larger. They are holding back tens of millions of gallons of water, and in the event that these things fail, the economic impact to the neighbors is going to be quite severe. So these are things that we need to always bear in mind and think, do we want to accept that risk? So this is an example of a catastrophic dam failure. This is something that has been on my mind quite a bit, particularly with the high rain event that we just witnessed over in Waverly, Tennessee, with all the flooding and loss of life there. Smaller but similar events can occur whenever a dam levee breaks. So that's something that we've really got to be cautious about and conscientious of. It seems like these past few years, this is just my opinion, that we've been having more and more heavy rain events and severe rain events, and been seeing more issues like this. And if something like this happens and it takes out a neighbor's soybean field and destroys several acres of soybeans, well, then you've got to take into mind how much that you're going to be liable to have to pay the owner of those soybeans or livestock or housing or whatever that this pond has destroyed. So that's another reason why we really want to be conscientious about how we build these ponds as well, because there is so much liability that can go into that. I was speaking with Mr. Baker from TDEC this morning, and he was telling me about a situation in a county not too far from where I'm at. A few years ago, a gentleman went in, he had retired, built a big $400,000 home. He wanted to put in a lake so that he could sit on his porch and enjoy his lake, just like many of us probably would. He went into a holler, built the lake without request of permitting, and built it with unsound construction practices. Tried to pack down quite a bit of chert rock in the levee, which is not known for being stable for holding water back to begin with. Within a few years, he wound up with a high rain event. It blew the levee, and they wound up with a great deal of pollution and issues in the creek downstream from him. He was held liable for that, and that's something that I'm hoping that all of us can avoid with our ponds. So as far as considerations for construction, we need to take into consideration the depth of the fish pond. I've got a lot of folks that I'll go out and they will brag to me that their fish pond is 30 some odd feet at the levee. I've checked a few of them with a shock boat and had a few of them that have come up 35 foot deep at the levee. This is actually not a good thing. It's quite the opposite. Really, the ideal depth on average for a fish pond is going to be right around 6 feet deep. Reason for that, if we get deeper than 6 feet, then we start getting into some water stratification issues, oxygen stratification, and oftentimes the deeper you go, the more oxygen devoid that pond is. And that in turn makes us more susceptible to a fish turnover event, a depleted oxygen event where our fish wind up dying because all of that depleted oxygen at the bottom of the pond, for whatever reason, has been pushed up to the top of the pond and is called a turnover. So we would really like to try to avoid having those ponds dug out at a point where they're getting into stratification issues, so that we can keep that water column oxygenated all the way through. And we also need to consider overall capacity, water capacity of these ponds. The way that we can figure that is to take 0.4 times the surface area times the maximum water depth at the dam. So here you can see we've got an example, 3.2 acre pond. Figure that up, it comes up to about 16 acre feet. 1 acre foot is equivalent to about 325,000 gallons of water. So by figuring out our capacity, that's also going to give us a big step forward whenever it comes time to figuring out how strong that dam needs to be built, and what the dimensions of that dam needs to be. And you'll hear me mention this a few more times in this discussion, but whenever it comes time to building a pond, especially if we're looking at building a larger pond, acre or so bigger, we really want to try to, I would recommend hiring an engineer or a reputable contractor to assist you with this. We can get that engineer some of the specifications that are needed through the ponds planning and design construction booklet. But we really need to get somebody that's reputable and that is going to follow those directions to not only build you a pond that is going to last long term, but also to build you a pond that is going to provide you the minimum liability in the event of a catastrophic failure. So we mentioned permitting earlier. It may be required by the Tennessee Department of Environment Conservation. Mr. Baker said that he would be happy to speak with anyone that's got questions about this. If you have got an area that you are not sure if it needs a permit or not, he can send someone out there to take a look at it and determine whether or not you truly need a permit for that pond in that area. Anything that is impacting a creek or a stream is going to be considered in need of a permit. That's going to fall under the State Water Quality Act. These streams and creeks, they are protected by the State Water Quality Act. And so in order to change them up any whatsoever, you are going to need that state permit. And the fact of the matter is, it is quite difficult to attain that permit. The thing that they like to look at is you may have a landowner that owns 50 acres along a small stream or creek. If he's at the headwater of it, he's figuring that he's not going to be impacting too awful much downstream anyway. He goes in and puts up a dam along that stream and dams him up a nice 10-acre lake. That will be impacting things downstream. The overflow from that is likely to be greatly reduced due to the fact that you're going to have a whole lot more evaporation off of a 10-acre lake versus a naturally flowing stream. And what they see a lot of the times is whenever we get these impoundments like this, that evaporation is going to typically take up whatever flow through would have been available for those small streams to begin with. So in order to keep it legal, in order to protect yourself, I strongly recommend, if you're looking at damming up anything even near a stream, contact TDEC and have them come out and take a look at it just to make sure that you are within the legal confines of the law. Then we get into design considerations. Once again, this is just going to be scraping the surface. We're going to be looking at design considerations for an embankment pond. There's several different types of ponds that can be built. Sometimes we see excavated ponds where they simply dig a hole in the ground. But most of the ponds that we're dealing with are embankment ponds where folks are putting up a levee to retain water in a holler or a depression. So things that we need to consider with this is slope and width, both of the dam itself as well as the slope of the land feeding into this pond. We need to consider a clay core within that dam and proper compaction of that clay core. And then we also need to get into looking at spillways. So whenever we talk about slope and width, this is in reference to the levee of the pond that we're dealing with. That's all going to depend on the type of soil that you have got on your property. Different soil types may require different fill material. Typically we're going to be looking on the upstream side, a 3-to-1 rise, which is going to be a fairly gradual, whereas on the downstream side, we're looking at a 2-to-1 rise in those clay, gravel, sandy stuff. Whenever we get into clay silt, we can go with a 3-to-1 rise on the upstream and downstream sides. As far as the height of the dam, that's what's going to determine your minimal top width. As you can see over here, we've got, if it's under 10-foot tall height of the dam, you can get by with a 6-foot top width. As the dam gets taller, obviously we want that top width to be larger as well. Once again, these are pulled from the Natural Resources Conservation Service guidebook on properly built ponds. We mentioned a little bit about clay cores. This is just kind of a rough example of what a clay core would look like. These are especially important in areas where we are dealing with soils that are a little bit more coarse. Those coarse soils such as sand and whatnot, as we know, are not going to hold water nearly as effective. And so at this point, it may become necessary to haul in clay and then compact that down in the core of that pond to prevent that water from percolating through the levee and causing those leaks on the backside. Here we've got an example of a vertical drain device with the standpipe and drain through the levee. You'll notice in the center of that levee, we want to make sure that we have got an anti-seep collar on these drains. Oftentimes, if you've got an old pond that was built back in 30 or 40 years ago, I've got a perfect example of one behind my house. It's 7 acres. It was built in 1980. They did not put an anti-seep collar on it, and we're seeing quite a bit of leaks around that pipe on the backside of the levee where that water is flowing parallel to the pipe through the levee and causing a pretty decent leak within that pond. So we strongly recommend putting those anti-seep collars in there with those if you're going with a pipe drain in ponds these days. Then we get into compaction. Once again, dozers are not built to compact soil. I've got a lot of guys building cow ponds. That's what they put them up with. They put them up with a dozer and compact them. They've got leaks on the backside, but then again, it's out in pasture. They're not too worried about it. If we're talking about building ponds to have around the house for recreation, to look nice and stand the test of time, we are going to have to compact that soil to reduce the overall pore space between those soil particles. That way we've not got water percolating through that levee. Pictured here, you see a sheep's foot roller. This is an implement that you can hook to the back of a dozer and just pull across that soil to compact it down and to reduce the overall pore space in between soil particles so that we don't have that water movement through the soil. Levees need to be compacted gradually in 6-inch layers. So by compacting those gradually, we're making sure that we have got most all of that pore space removed. We've not got any air space in between those soil particles, so that as that pond begins to fill up, there's nowhere for that water to go except but to stay in the pond itself. That's absolutely key to reducing the kind of leaks that we so frequently see of water percolating through these levees. It's going to cost more money. It's going to take more time, but in the long run, it is going to save you a lot of headache from trying to drain your pond down, put bentonite clay in, and spend lots and lots of money down the road in a situation where there's no guaranteed fix. Then we get into spillways, and this is one where it can get real technical real quick. Your principal spillway with vertical pipe, that's something that we like to put in there. We're going to need to have those built to handle water ranging from a 1 to 10-year flood frequency event in most cases at the bare minimum. A lot of this is also going to depend on the size of your pond and the inflow to that pond. I think this is for one that is below 50 acres. If you're building one that's larger than 50 acres, then you're going to want to try and plan for a 25 or 50-year rain event. But smaller than 50 acres, we can typically be all right with planning for a 1 to 10 year, 24-hour rain event. But from that, we also want to always put in a earthen spillway or a natural vegetative spillway for emergency use in periods of high precipitation. You're going to get high precipitation just like we did in 2010, just like we did last week. Sooner or later in that pond, we need to make sure that we have got ample spillway coverage through our pipe, but we also need to make sure that there's an emergency spillway so that it can take that route before it goes over the top of the levee, thereby blowing the levee. No matter how well a pond is built, if you don't get the spillway right, there's a good chance it's going to be destroyed the first time that we get a large rain. As far as earthen spillways go, we want to make sure that we take some preventative steps to try to prevent them from eroding. We can put in rock riprap to prevent that erosion from occurring. We can also go with putting in vegetation such as the grass, fescue, different types of grasses that will help to retard that water from rushing down that spillway and taking all those soil particles with it. And then wherever we build those spillways, we also need to be conscientious of our outflow. Where's that outflow going? Is it eroding the outflow? Because if it's doing that, eventually it's going to erode right back up to your levee over time. So the questions that folks ask, what dimensions should my spillway be? And to this, we come back to the standard lawyer answer that it depends. It's going to depend on drainage area that drains into your pond, surface acreage of your pond, effective height of the dam, erosion resistance factor for the soil. Different soil types are going to have different erosion resistant factors. Vegetative retardance factors. There's different vegetation that's going to be impacting that water differently. Expected discharge velocity and frequency and duration figures that we mentioned earlier. All of this is very, very important in figuring out your spillway and how it needs to be designed. And that is why I recommend work with an engineer. There's a lot of mathematics and science that goes into figuring out exactly how that spillway needs to be built in order to handle the water runoff for each specific pond. And it's going to be different with each specific pond. So that's why I say it really depends. There is no cookie cutter answer on this. That's just find somebody that is well qualified, work with them, have them come out, perform a site analysis, and determine it through engineering means. So that's kind of the quick and dirty. I went through that kind of fast. Like I mentioned, we're just scratching the surface here. There is a whole lot to be considered. These are just some of the basic bare minimum considerations that we need to look at. I would recommend y'all, these are available online to anybody that wants to type them in. Ag Handbook 590, Ponds Plans, Design and Construction, and then the Pond Conservation Standard. These are fantastic roadmaps to go by whenever it comes time to plan and design your pond so that you've got something that should withstand high rain events through the test of time and give you something that is going to be of value to you, your property, and to your loved ones, and provide you with outstanding recreation. We mentioned on here knowing the soil on your specific property. The Web Soil Survey is a tool that is provided by the United States Department of Agriculture. Once again, it's available to the public. I find it to be fairly user-friendly. This is something that you can get on. You can find your property, and it will give you a soil map of your property. It will tell you what the slope is. It will also tell you what types of subsoil that you're dealing with so that you know whether or not you have something that is going to be highly erodible, something that's going to potentially hold water or not. And it'll give you a pretty decent idea of what the foundation of your pond is going to look like, whether or not you're going to have to bring in additional clay resources or a pond liner to put in to help hold that water in your pond. And then once again, your district NRCS office. I might get in a little bit of trouble for mentioning that. I think they're trying to get away from working with private ponds on some of this, depending on which office that you're at. But that district NRCS office has got folks that are on staff. They're paid through public tax dollars, and they are actual engineers that can come out and provide you with technical assistance. Now, it used to be that they would help to provide some cost share assistance on ponds. I don't believe that they've done that for several years, but they can provide you with some technical assistance and know-how if needed. And so I would recommend to you to at least reach out to them if you've got questions about building a pond on your property and you need somebody to come out and look at it. And then, of course, you've also still got your folks at the Tennessee Department of Environment and Conservation that can assist with that as well. So I'll pause at that point, and at this time we can take questions. If any of y'all have got any questions pertaining to pond repairs or construction, and I will try to answer those to the best of my ability.
Justin, thank you so much. I appreciate all this information being in one place, and I think you've done an excellent job on that. With that being said, if anybody has a question, you can unmute yourself or you can type it in the chat box for Justin. Is there anybody with any questions?
Justin, Manny Badwell, quick question, and I'm this is showing my being around a while, I guess, but at one time we were told by TDEC that if you were doing a pond that was 5 acres or larger, even if it really was just a watershed pond on your own property that really, you know, you weren't disturbing a creek or anything, that required permitting. Is that still the case?
Thank you for asking that, Manny, and I was under that same impression as well. I called and spoke with Mr. Baker of TDEC this morning, and I asked him that question, and from the way that he explained it to me, if it's simply a watershed pond and it is not impacting a creek or a stream, if you're not damming up a stream or a creek, then you should be good to go ahead and build that without permitting. However, the catch there is, what does TDEC define as a stream or a creek?
Yeah, there you go.
If you've got a ditch running through your area, if you've got a spring running through, there is still the potential that they could define that as a stream or creek. So it's a little bit of a touchy definition. His recommendation to me was to contact them and have them come out. They can take a look and let you know if that questionable seepage might qualify as a stream or creek, and thereby add restrictions to your pond. So really and truly, that's the main thing is, what does TDEC define as a stream or creek? And if it's a ditch that has some flow through at certain points of the year, that may still fall under their definition. So that's where you've got to be careful.
Okay, I appreciate that, because I thought that might kind of have changed. I'll make one comment too, since I kind of deal with some of this in East Tennessee. This is a case where it is not one of those beg ignorance and that type of thing, because I do know a person that literally had to tear out almost a $40,000 construction project because he did not get it approved ahead of time. So yes, that is something that you don't want to beg forgiveness with TDEC on streams. They are not very forgiving on that, and I understand why.
Right. Yeah. Their main thing is, how is it impacting things downstream? So if you're putting something up and it impacts anything downstream, any at all, they're gonna look at that pretty hard. And so it's better to check with them and make absolutely sure that you're in the clear before you sink a bunch of money into it, than it is to go about it and plead ignorance. Because at the end of the day, they're not going to be too concerned with your ignorance. It's going to be one of those things that you probably should have checked on to begin with.
Exactly. All right. Thank you, Justin.
Thank you, Manny. And before you sign off, I know you deal with a lot of ponds over in East Tennessee. Is there anything that you would like to add, or any comments that might be helpful that I might have missed?
No, you covered it real well, and and I know everybody knows this, but NRCS offices, that you'll have people that will take a lot of time and work with pond owners, and you'll have some that just they've moved on to other things and they won't hardly deal with it. The other thing too, and especially with all this limestone and everything, and y'all know what I'm talking about, pond construction is one of those things that you just cannot guarantee. If the best construction company, the best equipment, everything done to the best of the contractor's ability, sometimes you're just going to have a failure, and it's just, you can't guarantee it. That's the only, tough thing about pond construction. You can try, it's one of those things you just cannot guarantee that it's going to be successful every time.
Right. I just wanted to switch back over to that resources page in case anybody needs to write that down. These are great things to discuss with your contractors, guys. I mean, it's your money, it's your investment. And I know a lot of folks that it becomes an heirloom investment. So I would certainly try to do it right the first time to save yourself and your heirs quite a bit of headache down the road. Any other questions?
Justin, this is Lee Salmons. I have a producer that has a pond. I know you're supposed to keep the bank clean, but it's got trees and all kinds of vegetation over the last 20 years that's grown on the pond. Will you create more of a leak by cleaning that off, or leave trees that are, 15, 16 inches in diameter growing on the pond?
That's an excellent question, Lee. And really, whenever you get to a situation like that, it's a darned if you do and darned if you don't scenario. If you cut them down, those roots are going to rot out within the next few years, and you're going to go ahead and have those leaks right then and there. Whereas if you leave them standing, you may not have a leak for several years, but the day's coming. So really, there's once you get to that point, there's not a real good solution. If he wants to, if it were mine, I would probably go on ahead and gamble and leave them, because if he cuts them, he's going to have those issues sooner rather than later. Whereas if they continue to grow, he may go for quite some time without a leak. But it is a problem. Typically, the rule of thumb I give to folks is if it's if it's 5 inches in diameter, 5 inches in diameter, usually you can cut it and get by, and those roots aren't going to cause you that much issue. Once you start getting larger than that, then you're running the risk of having those sizable roots. A good rule of thumb is you can look at that tree. Most of those roots are going to be about the same size as the branches that tree is putting on. And so that's the issue that you can get into. But really and truly, there's just not a good answer for that.
Thank you.
That's why it's so important to perform regular maintenance and keep those levees clean and clear. Now, a lot of times I'll get questions from folks about contractors. Is there anybody that we can recommend to help them build a pond? Answer to that really is unfortunately no. And the reason for that, the University of Tennessee, and it may just be a state policy more so than a UT policy, but we're not supposed to recommend one company or one business over another. And I do not have a list of contractors either, because I know as sure as I try to put a list together, I'm going to leave somebody out, and that'll cause a mess as well. So what I would recommend with you there is speak with your folks locally. Your folks with NRCS oftentimes contract these folks out, and they may be able to refer you to someone. But check with folks locally, and then of course the internet is always a right handy tool as well. We've got several different pond companies that's how they make their bread and butter is building and maintaining ponds. So I would check potentially with those.
Just to comment, Justin, in most cases, those NRCS contractor approved contractor list are public information. And the one thing you do know about those lists is they're insured, bonded, and they can perform government contract work. So at least, they've got all their official paperwork, banking accounts and all that in order. So that sometimes is a good place for folks to start, at least, is get that NRCS approved contractor list.
Absolutely. Thank you, Manny. I appreciate you bringing that up. All right, we got any other questions?
Any more questions for Justin? Okay. Well, thank you very much for being on with us today. Thank you so much, Justin, for presenting with us today on this topic. I've even during the presentation, I've had several people email me wanting a recording of this, so I think that's going to be great. I would also encourage you for our next lunch series that will be on September the 22nd. And Les Humble, who is an area farm management specialist, is going to be talking about some issues that beginning farmers and landowners may find interesting. So our next lunch series will be at 12 noon on Zoom on September the 22nd. So be sure to join us then.
Hey, Matt, this is Calvin. I think